students, welcome back to the another session of our data structure journey. Today we are going to learn double-ended queue and we are going to implement in the C language. So first we have to know what is a double-ended queue. By the name double end means both the end we can able to use. Generally, whenever you go for queue, that is the linear queue. Linear queue is a one type of data structure where insertion is done from one end and deletion is done from the another end. Means one end is specific for the insertion operation, another end is also specific use for the deletion. But double-ended queue is a linear data structure where insertion and deletion can be possible by the both the end. That's why it is called as the double-ended. Both the side we can perform insertion as well as the deletion. We can say it is a generalized version of the queue. Then it does not follow the fast come fast serve, because whenever we go for the queue, what happened, the element inserted in fast is going to be delete fast, but here what happened, insertion and deletion can be performed both the end. So this is a queue, this is the rear end, this is the front end. Rear end we are used for insertion and front end we are used for the deletion. But in case of double end, both the end we can perform insertion operation as well as the deletion operation. That's why it does not follow fast come fast out. Next one is the types of double-ended queue. So double-ended queue means both the end. Now what are the category? Category is two types. First one is the input restriction. Here input is restricted, means both the end cannot use for the insertion operation. Only one end can be used for the insertion operation. Output means that restriction is put in the output, means only one end it can be possible the output, means deletion both the end cannot possible to perform the. So input restricted, in this case insertion operation can be performed from one end, whereas the deletion performs on both the ends. So now this is the, here the deletion can be performed this end, from the rear end can be possible, from front end can be possible, but insertion can be possible from one end. That's why it is called as the input restricted queue. Then output restricted, in this case, the deletion operation can be performed from one end, whereas the insertion operation can be performed the both end. So output is restricted, deletion is restricted. So deletion is done from this end, as but insertion can be performed both the end, means front end and rear end. That's why it is called as the output restricted. So what are the various operations we can perform by the double-ended or dequeue? Generally, double-ended queue we called as the dequeue. First one is the insert operation at front end, insert from the at the rear end, deletion at the front end, deletion at the rear. Both then we can, so both then the deletion operation. Then get the front item from the queue, means what is the front item or what is the rear item. It can be possible. Then check whether the DQ is full or not. Check whether the DQ is empty or not. So is empty, is full. Another operation we can perform, that is the pick operation. Pick operation, here what happened? We can get the front as well as the rear. So these two operation is for individual front item, individual rear item. But if you go for pick operation, then it will retrieve both the get as well as the get the front information as well as the rear operation. So next we have to know what is a overflow condition. As we have to implement in the double linked list, so we are using the dynamic memory. There is no chances for overflow. So if we go for the array implementation of the double-ended queue, then there is a chances of overflow. But if you go for the linked list implementation, that is the dynamic memory allocation, so there is no chances of overflow condition. Underflow, there is a chances of underflow in case of dynamic memory allocation, means there is no matter. So here what happened in double-ended queue, both the end we require both the end linked precision, means there are two pointer we are using. One pointer for the front end, another pointer for the rear end. So here what happened? If both the front as well as rear points to the null, then we say the queue is underflow. Simple, if it is a front is also null, means it is a underflow. There is no data. So next operation, we have to know how to perform insertion at the front end. So this is the algorithm we have to follow whenever we go for the insert into the front end. So as we know, this is a queue. So from this end, we can go for the front end. This end we called as the rear. So for understanding the better, you can refer my double linked list video where we cover each and every operation, how to insert into the first and how to insert into the last. And so just think, here this is the first node, this is the last node. So if we think as a linked list, then what happened? The start node is same as the front end, the last node is same as the rear end. Same logic we have to follow here only. So here what happened? First case, memory allocation is not possible means whenever you go for memory allocated for the node, what happened? If the memory allocation is not done, then we have to simple make a memory allocation is not possible, insertion not possible. So here node is consist of three things because we are going to implement the double linked list. So this location is we are using to store the information part we want to go, or we want to store the data. You can think as a we store the data. This one is the back pointer of a node that store the address of previous node. This one is the next node. Next node store the address of next node. So the node consists of three parts. First part is the previous node, address of the previous node. Second one is the store the information or data we want to store inside the queue. Third one is the data or the address of the next node. So whenever memory allocation is done, there are two cases, whether list is empty or list have elements. List means right now queue is consist of number representation list means our queue is no information. So no information means what? For example, we create a node, memory allocation is successful. If the memory allocation is successful, then what happened? Simple, we have to create the node. For example, this is the 100 address. Store the information into the, for example, first information we want to store 10. Make the back and next pointer of newly created as a null. Why? Because it is going to be a first node. If the first node means there is no previous node, if the first node means there is no next node, so we have to store this one null value, this one is null value. Then what happened? After that, may now point front as well as rear pointer to the newly created. Now both the front as well as rear. So this is the front as well as this is the rear. So this is the front end, this is the rear end. So this is our insert at front end is successfully done. Otherwise, list have elements means queue have here what happened? Double-ended queue is represented by list. So list have the elements. So what happened? For example, this is our node. Then what happened? For example, queue have the elements 10, 20, 30. For example, now this is the double-ended queue. First node, second node, three information means three node we minimum we require. So 10, 20, 30. For example, first node address 100, second node as a 300, 200, 300. So first node, previous store which value, null value, next store which value, or back pointer store. So it points the connection. Now here it store the 100 address, make the connection here. Now it store the address of 300. So make the connection, forward connection now. 200, backward connection is done. So this is the null. So now this is a front pointer. This is our rear pointer. This is the representation of double linked list for the queue element 10, 20, 30. Now what is our objective? Insert at the front end. So front end we have to insert. So store the data into the memory allocation, that the case B means memory allocation is done. So now what happened? We have to first store the information. For information we want to store that is 25. So now we store the value 25 as insert at first position because you have to go for the front end position into the linked list. Make the back pointer of newly created as a null. So this is the back pointer. So back pointer you have to make as a null. Make the next pointer of newly created node to the front node. So newly created node this one. So now you have to store make to the connection to next. So if I store this one, then what happened? Connection established. Make the back pointer of front node because this is the front node. We have to make this node as a front. So this back is previously front. This is the front. Front back right now null. If I store this address, for example, this address is 400. Now I store the 400 address. Now the connection established to this node. So now both the connection, forward connection as well as the backward connection established. Now make the front as a newly created node. Now this is the newly created. Now we make this one as a front. So if you make this one as a front, then what happened? This front is already gone right now. Now insert into the first position is over or not. So insert into the first position is same as the insert at the front end. So now we in front end we insert a value or not. So right now 25 inserted in this. So this is the way we have to perform insert at front end. Next we have to know how to insert in the rear end. So here also first thing we have to check whether memory allocation is done by the malloc function, or if it is memory allocation is done, then it's okay. Otherwise what happened? You have to write down the error message that memory allocation is not possible. Rear end means from the last position we have to insert. So what happened? If the list is empty, means if there is no element in the queue, then what happened? Simple, you have to create the node, store the information. For example, information is then make the back and next point of newly created as a null. So we have to store null. Here also we have to store the null. Then make the new pointer as a so this is our front node. This is our back node. So now queue front is same as head as well as tail. So both are the same single node. Otherwise means list have element, element means the queue have element, because here the queue is represented by the number of nodes. So here, for example, this is our queue have the elements 11, 22, 33, 44, for example. Now, so 4 node we require 1, 2, 3. For example, this is one more node. So each node has 3 part: information, pointer to the back node, pointer to the next node. Address is 100, 200, 300, 400. For example, here the 11, 22, 33, 44. So now if we store the 200, this connection, if 100, this connection is established, 300, this connection, 200, this connection, 400, this connection, 300, this connection. Now this is our rear pointer, this is our front pointer. Now what is our objective? Our objective to insert a data into the front end position. So we have to insert the data into the rear end, sorry, not front end. So store the data into the information part. Before that, what happened? Memory allocation is done. So let us draw the memory allocation. For example, 500 is the memory allocation do. Store the data into the information part. For example, after that we want to insert 55. So we have to store the 55. Make the next pointer of newly created as a null. Why next pointer? This is the newly created node. Next we have to make the null because we are going to insert at the rear end. Rear end after rear, after that there is no element. So we have to make this one as a null pointer. Make the back pointer newly created to the rear pointer because we are going to the insert into the rear end. So this node back should be this value, this node value. So this node value is previously what happened, null. It stored the rear, next stored the null value. Now we have to make this node connection to the rear end. So what happened? If I store the 400, then what happened? This connection is established. But after right now the rear back points to the null value. If I make the rear back to this newly created node, then what happened? The both the direction connections. So that's why I make the next pointer of the newly created. So right now we have to store the 500. So it make the connection here. So this connection is done. So now connection is here. After that, what happened? We have to make this one is the last node. So this one is the last node means we have to make the rear equal to newly created node. Then what happened? If we make this one means this real is already gone. Now see. So insert into the rear end of a queue element is done or not. So this is the way we can perform the insertion. Now insertion from the front end as well as the insertion of the backend can be possible by help of the double-ended queue. Next one, deletion from the front end. So now we have to delete the element from the front end. So whenever we go for deletion operation, we have to little bit care that we have to think whether element is present inside the queue or not. If the element is present, it is a fast element or not, single element or not. If it is a single element, then what happened? After the deletion, we have to make the front as well as the rear pointer as a null value. So first we have to check whether the list is empty or not. If the list is empty, we have to simple. How to check? If front equal to null, it means that our list is empty means queue does not have any element. If the list have single element, how to check? If we make the start next equal to null, then what happened? List have single element. For example, this is a double linked list or the value of 10. This one is the null, this one is the null, this is the front. Because only one element. So now in our queue, only one element present. So what happened? So make the front pointer as a temp, print the data, we have to print 10 is going to be deleted. Then the make a front as well as the rear as a null. So now front points to which value? 100 value. Rear also points to here. Now after delete, we are going to delete. So that's why we have to make this both the rear pointer point to the null value. Then we have to release the memory. After that, what happened? We have to release the memory. Release the memory means then what happened? Front as well as the rear points to which value? Rear value. So null value. So if start with the front equal to the null value, then what happened? It is empty. Then we have to go for the deletion whenever the list have more element. List have more elements, queue have more elements. So we have to go for the front end. So for example, 10, 20 data is present, 30 is present. So this is a node, this is the another node, this is the another node. 10, 20, 30. Both connection is established. So this is our front end. This is our rear end. So what is our objective? Objective is to delete an element from the front end. So if you want to delete an element from the front end, then how to do it? So here what happened? First make the front pointer as a temp pointer. Now we have to make this one as a temp pointer. Now this is our temporary variable. This is our temporary variable. Then print the data to be deleted. Then we have to print that 10 is going to be deleted. Make the front pointer to the next node. So now if we make the front equal to front next, then what happened? Front point to this. Free the temp. Now we have to free the temp, which we free the temp means we release the memory. Then what happened? Now first element is deleted from the double linked list means our queue elements right now 10, 20, 30. Now element is 20, 30. So 10 is already deleted. So then how to delete the element from the rear end? We have to know how to delete. Same thing here. If the list have elements empty, means our double linked list is empty, then what happen? Our queue is empty. We cannot perform any operation. We have to simple print deletion not possible. If a single element, make the front pointer as a temp print that is the same case for the previous. So only the changes occurs whenever more than one element is present. For example, this is our queue. Queue representation of the double-ended queue. So double linked list. So here 5, 50, 20, 25 data is present. Both side connection is established. This is our rear end. This is our front end. What is our objective? Deletion from the rear end. So here we have to delete an element from the front end. So dequeue operation deletion from this end, because both the side we can delete, so we have to delete this element. So what happened? First we have to make this one as a temporary pointer. Print the data to be deleted. So we have to print 25 is going to be deleted. Then make the previous node of rear as a last node. So this node we have to make as a last node. So means we have to point this one. How to do it? If I write down rear equal to rear back pointer is there. So if for example, this is 100, this is 200, this is 300, this is 400. Now, so this store the 300 value, this store the 400 value or not? Right. So if I write down rear equal to rear back pointer, so what happened? Rear points to this one. So at that time, what happened? This connection is done. This connection is gone. After that, make the temp pointer as the rear points to the next pointer. So next pointer means this pointer right now. This next pointer points to the next node. If I make this one as a null, so this value we have to delete and we have to store the value of null. So this value is deleted and we make as a null. So if I make as a null means it's point to the null. After that, we have to delete the value. After that, we delete the value. Once we delete the value, then what happened? So deletion from the rear end is over or not? So Q, if we represent a Q rear side is element is over. So in this case, we have to implement the double-ended queue by help of the double linked list. Next, we have to go to the our implementation phase. Let us do the implementation. Here, implementation of the DQ using the double linked list. We need two header file, standard input output for printf scanf and stdlib, that is the library function we require for malloc function, because here we are implemented the dynamic memory allocation. For that we have to go for malloc function. That's why we need. So here we have to go for the structure declaration of the node. Node has three parts in this because we are going for the double linked list. Means linked list has three elements. First one is the information pass or data we have to store. Then another pointer points to the address of next node. Then pointer to the address of previous node. That's why we make as a back pointer. So there are two pointer, next as well as the back. So for the queue, we require two pointer, front pointer as well as the back pointer, that is the rear pointer. So we make the front as a null value initially. It should be initialized with the null value. Then so we initialize the both pointer. Then fast function we have to write down for to insert an element into the front end from the for the dequeue. So void insert front. As I have already told you that I always prefer to make the function does not take any value, does not return for simplicity. So here first we have to allocate the memory if you want to insert the data. So we have to allocate the memory. For example, the pointer store the newly allocated memory is the PTR. Then we have to allocate the memory by help of the malloc function. Then we have to check whether memory allocation is done or not. Maximum chances is memory allocation is done, but still we have to check. For a good programmer, we have to go to the all the cases. We cannot bypass the any cases. Memory allocation is not done. Okay. So this is the if case. Else case means memory 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 allocation is done. Then what happened? If the memory allocation is done, then we have to ask the user to enter the data into our double-ended queue. So we have to write down printf, please enter the data into the queue. Then we have to scan. We have to use the scanf function. Percent num. For example, num is the variable to read the value. So we have to declare the num variable also. So once we read the value, then we have to store the information part before. So the data we have to store in the info part at the now. Then we have to think which location we have to adjust the pointer. So first thing we have to check whether our queue is empty or not. So queue is empty means if front equal to null. It means what? Queue is empty. If queue is our empty, then what happened? If queue is empty means that we have to make the newly created node as a front as well as the rear. So we have to make the ptr backside equal to ptr. Next, both the pointer we have to make as a null because it is a first node, so we have to make the null. Then we have to make the front equal to rear equal to newly created node. Newly created node is the ptr. Then else means what? Else means list have more than one element, more or one element. Anyhow, we have to insert the node into the first position. If the first position we have to insert, that is the front end. So front end back nodes, back pointer always point to the null because it is a double linked list. So we have to make the ptr back because it's going to be insert into front side. So we have to make this one back equal to null. Then it's going to be inserted into front end. So we have to make the ptr next equal to front value. Then front because it's going to be insert into front end. So front, but whatever right now front node back right now point to the newly created node. Newly created node is the ptr. Then make the front as a ptr. Then we have to make the front as a ptr. So insert into the front end is done. So this is after if and both the case means if this case we can write down our insertion in the front end is over. So we can write down printf new line insert at front end of dequeue completed. So this is the function for insert at front end of a double-ended queue. So it is completed. So this is our function is completed. For the first and front end is over. Then we have to go for insert into the rear end. Both the end insertion can be possible. So we have to go to the next end also. Last end that is the rear end. Because double-ended queue insertion can be possible both the ends, so we have to go for the insert into the rear. It is same as the inserted node at the end of the double linked list. Same logic we have to follow here. So here what happened? Anyhow, we have to allocate the memory. So I have to write down ptr star ptr equal to then we have to check whether memory allocation is done or not. But maximum chance memory allocation is done. But still we have to consider all the case. If memory allocation is done, then what happened? We have to ask the user to enter the data. Okay, whenever they will enter the data, after that the new line will be created or gaps will be present. Let us do this. Otherwise, Whenever we go for the complete program, it will not looks good. Let it wait for 10 tab, not the new line, it will wait for one tab. Okay. Then we have to scan if, for example, we store the num. So here we have to declare the num, integer num. So once we store the value, then what happened? Information, first we have to store ptr. Then only we have to think which location we have to insert. Then we have same thing here. We have to check whether it is empty or not. Empty for empty. What we have to check? Empty queue front equal to null. If it is null, then what happened? Same thing we have to follow for the empty links ptr next equal to ptr back equal to null and front equal to, because this is a newly created node, that node is same as the front node as well as the rear node. Else means already. So this is the case for u is empty. Else means it has element. So here one thing, the element is going to be insert into the last position. It going to the last position means rear position, means the last node next always points to the null. So we have to make the ptr next equal to null. Then ptr back, because it's going to the last node. So ptr back is equal to which value? Rear value, because we are going to insert in the last position. And rear next we have to make as a newly created node, that is the ptr. Then we have to make the rear as a ptr. Then only the insert at the end position is completed. So insert into the rear end is completed. So this is the function we have to do for the insert into the rear position. Then we have to go for the delete function. So void, as I have already told, I always make the function does not take any parameter, does not return. Because if you go for it now, it can be easy if you are in thorough in the programming of the things. That's why I make the function as a very simple so that anybody can able to use it. So here, anyhow, we require a node type pointer which store the deleted node. So that's why we make the node temp. So temp is the pointer which store the address of deleted node. So first we have to check. Whenever you go for deleted, at that time you have to check whether data is present or not. If null, front equal to null means queue is empty, so nothing to can be possible to delete. Then what happened? You have to print that printf new line queue is empty, deletion not possible. It is our choice what we want to write down in our output screen. Else means front has some value, data is present, we have to delete. Eh, so what is it? It's a deletion from front end. So we have to store temp equal to front, then we can make the front equal to front next. Then what happened? Our deletion is over. Then we can make the front equal to front next. So front now connect to this one. Now we have to write down which element is going to be deleted. Then we did simple release the memory by help of the free function. %d deleted. You have to write down which element is going to delete. So it is temp info. Info, we store the data value. That's why we have to access the info part. Then free the temp. Our deletion is over. So delete from the front end is completed. So next function we have to write down, that is delete from the rear end side. So rear end means we have to delete the rear value and make a connection here to the previous node of the rear. So for delete same thing here, we have to declare a pointer to store the deleted node. So here we have to make the pointer declaration, then we have to check. Same thing, whether data is present or not. If front equal to null means queue is empty. Then what we have to do? We have to print if queue is empty. Deletion not possible because there is no data. Else data is present. So what we have to do? We have to go to the last node. So last node we have to print because it is a last node, or there is a chances that it is only single node. If the single node means after deletion we have to make the node as a after deletion we have to make the front as well as the rear as a null. So here what happened? We have to check another condition that whether it's a single element or not. How to check? If the front next equal to null, it means you have single element. If the single element means what? After deletion you have to make the all the pointer, that is the front pointer here equal to null. Then we have to write down the printf. Then you make the front equal to rear equal to null. You make before that we have to just print the value before the release of the data. %d deleted which value? Temp info. So this is the case for single element. Else means list have queue have queue list means representation in the double list. So queue have more than one data. Then what we have to do? If more than one data, then what we have to do? We have to make the temp equal to rear value. Then make the rear equal to rear previous node. So how to access the previous node? By help of the back node. So back node. Once you make connection, then make the rear as a last node. So we have to make the rear next equal to null. Then we have to print and then release the memory. The same things we have to do. So I just copy paste here. So no need to write down the same thing multiple. So our delete from the end is over. Once deletion is over, so we are completed delete from the rear end, delete from the front end, insertion is over. Then one more function we have to write down how to print the data present inside the double-ended queue by help of the doubly linked list. So here what we have to write down, whenever you go for display, again you have to check if front equal to null. If front equal to null means there is no data to print. You have to write down printf new line queue is empty. Else means data is present. So what we have to do? We have to print the data from front end to rear end. So front end to rear end means we have to declare a pointer that stores the address of front node. So We have to require a font pointer, so we declare a temp is a pointer, we store the value. And up to how much we have to print whenever we reach the null value. So while temp is not equal to null, we have to traverse. What we have to do? We have to print only. Print a new line. Now print %d. After that, one tab should be present so that we can have the gap one tab between the elements. So temp info, then temp equal to temp next means we have to move to the next node. Temp equal to temp next. So here before that we can write down the queue elements are. So this is our display function is over. All the function is over. Right now we have to go to the main function, that is integer main function we have to write down. So here the things that we have to go for the two cases, that is the input restricted as well as the output restricted. Same program we are going to perform input as well as the output. So we have to write down the printf new line dequeue implementation using doubly linked list. Then new line will be created. Two new line will be created after that. Here what happened, we have to go for ask the end user whether they want to go for the input restricted or output restricted. So for that we have to ask the user new line. One is for the input restricted dequeue. Then new line will be created. Two for output restricted dequeue. Then new line will be created here also. One dot. After that, new line will be created. 3 for exit. Then new line will be created. Whatever we enter, for example, we store in a variable that is %d. It is choice. For example, choice. So we have to declare integer choice. Okay, once we enter the value, then we have to put into the switch case. Choice. Then we have to put into the switch case. Then case 1 is for input restricted case 1. Again case 1, what happened whenever you go for input restricted means you have to ask the user whether you want to insert into the front end or delete front end or delete from the rear end. So here also we have to go for another do case, that is do while. So do means the enter user has to enter which value they want to go for. New line. One is for insert at front end of dequeue. Then so input restricted means only one side we can input, so delete from front end, then delete from rear end. We insert, then we also want to display. So for each for display Then new line will be created. Then semicolon. Whatever we read, it should be scan. So scan a percent D. This is the option. So option means we have to insert the option value also. We have to declare the option also is a variable. So once we declare an option, then we have to put the option to the switch case. Here case 1, insert front, then break, case 2, delete front, then break, case 3, delete, then break. Here only case, no, display is there. So we have to write down case 4. Default we have to write down invalid. So this is the switch case. Once switch case is over, then do while it is for the what happened? It is for the case 1, that is the input restricted. Then we have to go to the case 2. Case 2. Case 2 also same thing. That is, we have to go for same do while, only input output restricted we have to change it. So I can make a copy paste. But here what happened? 2 is for delete from the front. This is for insert. Insert at rear end. So this is insert. We can do like that only. Then display. Okay, let us see. Okay, do is over. Then this is the case for do while. Okay. So do. Here also we are not write down the once we start the while means here do while option is not equal to 5. This is the end. So it's the same thing. We have to write down the case 1 because here also we use the do. So there is no while statement we have written. So we have to write down while. So case 1, case 2 is over. Uh, case 3 is the exit. Okay. Case 3 is okay. After each case, we have to go for the break statement also. Break. So here while after that break should be present. Case 2, then case 3, that is exit means printf. We have to write down new line. New line. Exit point. Then break. For the case 3. Otherwise, default for the first case, default printf new line. New line, then what happened? We have to, it is for the choice. Okay. Invalid choice. Then break. After that, we have to go for break. Once the break means our is over, then do is also over. Once do is over means, okay, I have already answered more. Okay, no problem. So this is for this one do while case. The while case, it is for which case? It is for switch case is over. For main inside the while case, we have to use it. So this comes to this while. Here, while choice is not equal to 4. Okay. Okay. I hope we completed all the coding part. Let's see whether it's completed or not. Hope so. Let's compile that program. Type, okay, type def, okay, type def. No start from, okay, semicolon happen. What is the error? Display. What is the function name we declare? Let, because function which, okay, display. Okay, right now, no compilation error, but let's see whether we are getting correct answer or not. Insert from the front end of the dequeue. Okay, input restricted. Okay. Okay, then insert the data. For first, we have to insert the data 10, then 40, then 30, then 40. For example, 4 element we are inserted. Now we go for display. Display. Here insert from the front end. So first 10, then we insert 20, 30, 40. Yes, insertion is done. Insertion from the front end. Front end means this is the front end, this is the rear end of the queue. Queue has right now 4 elements 40, 30, 20, 10. So front end is 40. If I go for 2, 40 is deleted. Yes, 40 is deleted. After that, I go for display. Okay, display also the element is deleted. Now, delete from rear end. Rear end is this end 10. If I go for 3, whether we are getting 3? Yes, we are getting the correct answer. Okay, let insert some more value 20, 30. Because 30 is not display element, so 55 or 50. Again, I insert the value 70. Now I go for display. Display element is the 70, 50, 20, 30, 20. Okay. So front end I have to delete means 20. Yes, we are getting correct answer. If I go for 3, 20, again 30, then 20, then 50, then Q is empty. Hence deletion not possible. So input restricted, we are getting the correct answer. For input restricted, we are getting the correct answer. Let us run the program once again for the output restricted. Because whenever we do any program now, we have to try all the options. So output restricted. So here insert and as well as the deletion can be possible both end, but insertion can be possible both the end. For example, 1, then we enter 20, then 30. Then I go for display. Display is 4. So insertion from the front end 10, 20, 30. Now I have to insert from the rear end. That is 3. 33, 3, 44, 3, 55. Now I go for display. So after 10, we enter the value from the rear end. So that's why 33, 44, 55. Yes, we can able to insert from the front end as well as we can insert from the rear end. Now we have to go for the delete from the front end. Means only this value we can delete because it is output restricted. Output means deletion can be done from one end. If I go for 2, then 20 deleted, then 10 deleted, then 33, then 44, then 55, then queue is empty because there is no data right now. So if I go for display, queue is empty. So hope you are able to understand the implementation of double queue by help of the double linked list. Why we are using the double linked list? Reason is that we can use the single linked list, but here double linked list is more flexible than the single linked list. And for insertion enqueue and dequeue, we are getting the line complexity is order of 1. That's why we are using the double linked list for the dequeue operation. And my previous video, I have already covered how to implement the double-ended queue by help of the queue. At that time, we are using the circular queue for the double-ended queue. So this is our complete program. We are already got the correct answer. So this is the function we are used. Hope you are able to understand the concept properly. Thanks for watching the video. Please subscribe the channel, like the channel and share the channel. Thank you so much.